for habitable exoplanets. The image captured by James Webb should be so detailed that we'll be able to detect the presence or absence of atmosphere on Proxima Centauri b, because if the planet has an atmosphere, its winds will redistribute the heat to the cool side of the planet. As such, it will be possible to measure how much heat the planet radiates in an infrared range. As the planet moves along its orbit, we will mostly have the view of its cool side, depending on the way it's positioned. If the planet has an atmosphere, the heat will be distributed more evenly, and there'll be less fluctuation of heat along the orbit. On the other hand, if the planet doesn't have an atmosphere, then the heat exuded in our direction will fluctuate dramatically as the planet moves. In other words, for the first time in astronomy history, we have a chance to directly observe the planets beyond the solar system. This opens a whole world of opportunities. We'll be able to not only detect the existence of an atmosphere, but its exact components. For example, the presence of ozone, because it would absorb some of the frequencies of infrared light waves, leaving distinct gaps or lines in the spectrum. James Webb can record these. Let's say that a hypothetical alien civilization observing Earth discovers distinct ozone lines in the Earth spectrum, which would enable them to conclude we have an ozone layer, and subsequently, oxygen, which makes life possible. We could make the same conclusion.
Fall calls for warm bowls of delicious food. Cozy up with a flavorful serving of slow cooker potato soup or opt for some creamy and classic pureed tomato soup. Find both recipes at stopandshop.com.
Let's say that a hypothetical alien civilization observing Earth discovers distinct ozone lines in the Earth spectrum, which would enable them to conclude we have an ozone layer, and subsequently, oxygen, which makes life possible. We could make the same conclusion. Furthermore, James Webb can determine the axial tilt of a planet, as well as its size relative to the size of the star. All of these are very important parameters, which we'll learn to apply in the future when the Space Telescope fully begins its mission in Lagrange Point L2 in the summer of 2022. And in the meantime, the telescope is being calibrated and prepared for the initial observation before uncovering the deepest secrets of our universe. When we talk about JWST, we're talking about the imminent future of studying exoplanets. But what if we look a little bit